Thank you guys for joining today for this tech talk. My name is Sawmill. We're going to be talking today about model serving with Chassis and Modzy. Quick agenda slide. First, we'll talk about what model serving is, some of the typical challenges associated with model serving, and then we'll talk about Chassis, what it is, where it fits in, and its overall goals. And then we'll jump into a little bit more of a hands-on demo. So, model serving can be broadly defined as hosting machine learning models that you've developed and making them available for inference via APIs. The goal of this is to allow them to be integrated easily into different applications so that you can actually start making use of them. Turns out this can be quite difficult for a variety of reasons. First, data scientists, who are typically the ones developing the models, their objectives and their skill set typically differ from DevOps engineers who are great at running production systems. And so there's a bit of a gap there. Additionally, different models have different input formats, output formats, dependencies, and you might want to deploy your model to different environments, ARM64-based devices, which would typically be edge devices. You might want to leverage GPU. Some models you might want to run on CPU. So a lot of variability there. And then once the model is deployed, you might want to manage, scale, and monitor them. And that's really where Modzy comes in with a bunch of rich functionality. But these are the typical challenges faced. So Chassis helps address several of those issues. But what exactly is Chassis? Well, here at Modzy, we've found that we've worked with a ton of companies that develop really great machine learning models, solving different business use cases. And they've got these great data science teams, but typically, in a lot of cases, they've got little understanding of how to transition those models into production settings and actually start getting your ROI on those models. So, through these experiences, we've learned a lot of lessons. We've codified them and sort of provided them back to the open source community in the form of the Open Model Interface, or OMI. And I'll get into that a little bit later in the talk. But once that OMI spec was in place, we built an implementation of it called Chassis. More specifically, an implementation of a tool that allows you to easily build OMI compliant models. So I touched on this a little bit earlier on, but data science teams are great at building these models, but their objectives are typically to get the highest performing model, not always necessarily to write the most efficient code or structure the code in a way that makes it amenable to deploying to a production setting. DevOps teams are great at that other piece, running production systems, but they, in a lot of cases, don't have the machine learning expertise. And as you can see, a bunch of the tools required on each side, there's a bit of a gap there, right? So your typical DevOps engineer won't be a TensorFlow expert. Your typical data scientist won't really be a Kubernetes expert. And so there's a bit of a gap there, and that's sort of the gap that Chassis aims to bridge. So to kind of summarize Chassis' goals, long-term goals, which we've made a lot of progress towards, we want to provide a simple tool mechanism to allow AI models developed in a lab to be able to be run anywhere in a variety of settings. We want it to be super easy to use, so you make a request to build your image using our Chassis Python SDK, which has a small set of dependencies. You as the model developer using Chassis don't really need to be familiar with all of those technologies, Docker, Kubernetes, etc. So no real DevOps knowledge required. And the goal is for that model to be able to be run anywhere. And we've made a lot of progress towards that. Models run through Chassis or deployed through Chassis can be run in a variety of settings. And I'll talk a bit more about that when we go through the demo. All right, so let me end the slideshow and jump over to the demo piece. Give me a second here. All right, so this is the chassis.ml site. If you're interested in learning more, I highly recommend that you check this out. It's just called chassis.ml. But Chassis, as I mentioned, builds models directly into DevOps-ready container images, ready for production inference. It uses two key technologies under the hood, so MLflow and Canico. MLflow provides this really nice generic PyFunc model interface, and it also is really great at inferring automatically all of the dependencies required to run your model so that you don't need to worry about manually defining that. So those are the two ways that we use MLflow, and we use another open source tool called Canico, which I believe Google developed, and it allows us to build model images within Kubernetes without actually requiring access to Docker. So those are two key technologies that Chassis uses under the hood, but we've abstracted all of that away for the user, so you as a Chassis user don't really need to worry about directly interacting with either of them. Now, as I mentioned, Chassis generates open model interface compatible images. And if you're interested in learning more about that specification, I highly recommend checking out openmodel.ml. There's sort of a general overview there. Essentially, OMI is a spec for multi-platform OCI-compatible container images. It's the way that we feel machine learning models should be containerized and the interface that we feel that they should expose. So the spec is detailed on the site, and the rationale behind the spec is also provided as well. So recommend checking that out. So those OMI compatible images are multi-purpose, and they can be deployed in a variety of environments. So you can run them locally on your laptop if you'd like. You can run them also on platforms like Kserve and Modzy. So quick overview of the architecture. Chassis consists of two key components. There's the SDK piece and there's the service piece. So the user directly interacts with the Chassis SDK. It's in Python, and will sort of ask for a minor refactor of your model code. You'll then submit through the Chassis SDK a full-on job to the Chassis service, which is deployed on a Kubernetes cluster. So today the demo I'll be showing you, the Kubernetes cluster we'll use is local minikube, just running on my laptop here, but Chassis can also absolutely be deployed to a full-on multi-node cluster. And so once you submit that request, Chassis is going to spawn jobs that will actually perform the model image builds, resulting in those OMI compatible images that can be run in different places like Kserve and Modzy. So it's pretty easy to get started. Let's say you want to do what I'm going to do today, which is run this on local minikube, just on your local machine. You have to install a few dependencies. You do a Helm repo add, if you're familiar with Helm, or even if you're not, you can just run these commands and it should just work. You run a Helm repo update to get the latest version. Then you install the Chassis service into your cluster. You run a couple commands to make sure that it's running. And then you'll do a port forwards to make sure that you can access the service via localhost, just like this. And just like that, you're up and running. So at that point, how does this actually work? So this is sort of a general outline, a generalized outline of the user's experience using the Chassis SDK. So you'll just pip install the Chassis SDK like this. You can use whatever your framework of choice is, whatever you've developed your model in. Chassis supports most frameworks. And you'll load the model in along with anything else that's required to be loaded into memory once and persist across inference runs. And so I'll show you a more concrete example of that in a bit here. Next, we'll perform that minor refactor that I mentioned earlier. So this process function is required to take input in bytes format and do everything that needs to occur to go from those bytes to a final formatted inference result. So that includes pre-processing, running inference, and post-processing. If you'd like to split these into separate functions and make things a bit more modular in that sense, you can do so as well, as long as you call them from within this process function. And I guess one more thing I want to mention, anything that you've loaded into memory up here can be leveraged within this process function. So next, you're going to initialize your Chassis client. You're going to point to a running instance of the Chassis service. So in our case, it'll be localhost 5000, since we're running on local minikube. And you'll call create model, and we'll pass that process function that we defined above. And then we're ready to submit the actual full-on model image build job to the Chassis service, just like this. And these are the 4 required arguments. So this is sort of the general outline. It'll work in a similar way, regardless of what your model type is and what framework you've used. Before I jump into the actual sort of more concrete example, I want to point out this SDK reference in the Chassis site. There's a ton of good information here, and all of the classes and methods are pretty well documented along with examples. So I recommend checking that out. Okay, So let's jump into some actual code. So what we're going to do in this notebook is we're going to go ahead and package up a PyTorch ResNet 50 image classification model into an OMI compatible model image. So at the top, we're going to do some imports. We're going to import our chassis SDK, and then some more model-specific imports, so PyTorch, Torch Vision, NumPy, etc. Next, we're going to enter some credentials which are required. So chassis is going to go ahead and push your model to your Docker Hub. We need to provide those credentials here. And then optionally, chassis can deploy your model all the way through to Modzy. And if you'd like to do so, you need to provide a valid API key. I've already done so. Next thing you're going to do is you're going to load everything into memory that needs to be loaded once and persist across inference runs. In this case, it'll be our actual model. We're going to use one of PyTorch's pre-trained ResNet 50 models, pre-trained on the ImageNet dataset. We will then load these human-readable labels so that we can map the output class indices of the model to human-readable labels like cat, dog, basketball, etc. We'll also load our pre-processing step here, our torch transform, and for now we're going to run this on CPU. So we go ahead and define those. Next, we're going to write that process function that I described. So we take bytes as input, we run pre-processing, we submit the pre-processed input to the model, and then we post-process the inference results into a nice format that we'd like to eventually return to the user. Next thing we do, we initialize our chassis client via the chassis SDK, point to our local running service, chassis service that is, and we run chassis client.create model passing that process function that we defined earlier. And I've got this local image of an airplane sitting on my laptop. We're going to be able to go ahead and pass that file path directly to the chassis model and test things to make sure that they are working as expected. And it looks like they are. We've got our inference results formatted here. So optionally, we've also got this functionality called Testdmv. What this is going to do is you can sort of think of it as a dry run prior to running a full-on chassis build job. On the service side, it'll go ahead and create your environment with all of your dependencies, and it'll try to test the model within that environment with your sample file to make sure that your dependencies are sufficient. We're not going to do that here because it takes several minutes to run. All right, so now we're ready to actually submit a job to chassis. And so as I mentioned in that outline page, there are only these 4 arguments are actually required. So that's the model name, the model version, and then your Docker Hub credentials. And optionally, if you'd like to deploy all the way through to Modzy, you also need to provide a sample input file, your Modzy API key, and a URL to a valid running instance of Modzy. So we'll go ahead and kick that off here. You'll notice that we didn't define any dependencies manually. So as I mentioned, MLflow, really nice functionality to be able to automatically infer all of the dependencies required to run your model. So you don't need to worry about that at all. Although if you do want to define your Conda environment manually, chassis does have support for that as well. All right, so since we got that okay, that means the job has been submitted. So let's check our pods. This is the service pod, and as you can see, this one's 11 seconds old. This is the pod that's actually running the model image build job. So that was just spawned, and then if we check the logs, we should see an image build underway. And it looks like that is actually the case. Now, this image build is going to take several minutes, and so in the interest of time, I'm going to go ahead and kill that job. I've got an image resulting from a previous chassis running. So I basically did a Docker pull from my Docker Hub from a previous chassis run, and I made sure to map out the port so that we can access it via localhost externally from the container. And so that's running, and we'll go over to Postman. So if you're not familiar with Postman, it is a piece of software that's really helpful in designing and testing APIs. And it does have gRPC support, which is great for us. And what I've done is I've downloaded the OMI proto file defining the interface that these models will expose. and imported that directly into Postman. And I'm pointing to my localhost 45,000, which is what the model container is exposing. What we'll do is we'll go ahead and first run this status route. So we got a response back, it looks like, and the model has returned a ton of useful information about the model. The name, the version, the author, input and output information, those sorts of things. And then we can go ahead and actually submit an inference job by hitting the run route. And so I've constructed the payload as followed here. There are, as you can see here, there's more information about how to structure this input on the chassis.ml website. But what you're seeing here is a base 64 encoded image, I think, of a basketball that I've got sitting locally. So let's go ahead and run that. And it looks like inference successfully completed, and we've got this base 64 encoded result. So we'll need to copy that. We'll go back over to our browser, paste that in here to this online base 64 decoder, and we see that we get our inference results, and it's correctly classified as a basketball. All right, so that was running the model locally. I've also got I mentioned that you can deploy all the way through to Modzy. I've done so previously, and this is the corresponding model ID and version. If we had completed this actual chassis build job, then through that final status from the chassis build job, we could pull directly our new model ID and model version and directly submit an inference job to that model. But for now, I'm going to use a previous run, and we can go ahead and submit an inference job to this model running on Modzy as well. So we'll give it a second here, and looks like we get the same inference results as above. Airliner, about 92%, same thing. So we've run it locally, we've run it on Modzy. I mentioned we can also run it on kserv. And there's a bunch of information on how to do that on the chassis.ml site on this page. But essentially what you need to do is structure your YAML file like this, point to your newly created image. This is the most important environment variable. Specify the interface as kserv. And then you're basically doing a kube control apply, pointing to that YAML file, and that will spin up this model in kserv mode into your Kubernetes cluster. All right, so the previous example was a single input example, so no batch inference support, and that was running on CPU. But what if we want batch inference support and we want to run on GPU for performance purposes? Well, the good thing is Chassis got support for that as well. So this notebook, we're going to use the same PyTorch pre-trained ResNet 50 image classification model. So a lot of it will look the same, but I'm going to point out a few points at which it deviates. All right, so the first thing is we're going to specify our device as CUDA. That's PyTorch syntax. And then instead of defining our single process function, we're going to define a batch process function. And instead of accepting a single input in the form of bytes, we accept a list of inputs in the form of bytes. We are then responsible for pre-processing all of them, running inference on all of them. And as you can see here, we submit the entire batch of inputs at once to the model to get that performance benefit. And then we're responsible also, finally, for post-processing every single individual result and returning a list of those formatted results. Then we go ahead, just like we did last time, we spin up our chassis client, and we run chassis_client.createModel, instead providing now our batch process function rather than our single input process function. And we also need to give chassis a batch size so that the resulting model image knows how many images it can accept at once, or inputs it can accept at once. After that, we've got this test batch functionality. We just point to a local file path, and Chassis will go ahead and repeat that input batch size number of times, run that through at once, and make sure that the batch functionality is working as expected. Now, one thing I do want to point out is that we only provided a batch process function here, but this Chassis's got some internal logic so that this will also accept a single input, and vice versa. If you only provide a single input process function, but a batch of inputs come in, Chassis will handle the logic. Now, you won't get the performance benefit of submitting all the inputs to the model at once, but everything will still be processed. You can also optionally provide both the single input process function and the batch input process function, and then things will be treated differently whether or not in the case that a single input comes in or a batch of inputs comes in. So chassis has got internal logic to handle all of that routing. All right, so the last thing that's different here is that we're going to specify GPU equals true here in our chassis model.publish call, and that will tell the chassis service that it needs to use a base image that's compatible with GPU. It's got CUDA and everything else required installed into it already. And that's it. Once that chassis job completes, you can run your model and it can leverage GPU. Another awesome piece of functionality is just like we said GPU equals true here. If you set ARM64 equal to true, then chassis will automatically be able to build an ARM64 compatible model image. So if you want to deploy to an edge device, you want to deploy to a Jetson Nano or a Raspberry Pi, for example, you can do so as well. And the really nice thing is that since we use internally we use emulation, you can actually build model images for ARM64 without having an ARM64 based node within your Kubernetes cluster to which the chassis service is deployed. All right, so I do want to point out, if you go to our repo, which is github.com/modzy/chassis, and then you go to the chassis.ml SDK subdirectory, and then you go to examples. There are a wealth of examples here, a ton of different model types, and from a bunch of different frameworks. There's an example here if you want to manually specify your dependencies, your Conda environment. This will show you how to do so. So I highly recommend checking out a bunch of these different examples just to see how this thing works in a bunch of different ways. So yeah, this is an open source project. There are a ton of issues that we filed here, things that we'd like to get to in our future roadmap. We'd really like folks to get involved. So if you would like to use chassis, we really welcome you to do so. As you're using chassis, if you see deficiencies, areas of improvement, or pieces of functionality that aren't there that you feel should be, you're welcome to submit a PR. We would absolutely welcome that. So please go ahead and check out our repo, and if you'd like to contribute, that would be great.